So specifically, I've selected 5 areas to focus on in the discussion today. The first will be load combinations for foundation design, and this is probably the most common confusing item that I see engineers get caught up on. And so I'll talk through the common issues that I see, and then walk you through the code provisions and how to interpret these clearly to efficiently complete your foundation designs. Next, I'll get into liquefaction risks and how to address them. This is also a commonly misunderstood topic, and there's recent code activity developing some standards on how to address these that I'll walk you through that will hopefully give you a better starting point in addressing liquefaction risks. After that, we'll have the 5-minute break and a Q&A session. Following the Q&A session, I'll discuss the basics of soil structure interaction and how it really relates to typical design parameters. Soil structure interaction is something that is a common, I guess, a hot topic these days, and many people don't really understand what we mean by it. And so I'll try to break it down simply so that you have a better understanding. I'm not going to get into the nitpick details of it, but I'll give you a brief overview of how it should really be implemented in practice. And then we'll roll that directly into map foundation design. There's a lot of overlap between these two topics. I'll split the map foundation design section into 2 parts. So after the first part, we'll have the second break and Q&A session. And following that, I'll finish the map foundation design, and then we'll go into deep foundation detailing. I'll walk you through current provisions and give you some background to explain that should clarify some of the common questions and mistakes that I see in practice. So with that said, let's dive right into load combinations. So as most people understand, when we're designing foundations, typically we need to use both an allowable stress design approach and an LRFD, load resistance factor design, or ultimate strength design approach. People are familiar with the 2 types of load combinations, but just to be very clear, the allowable stress ASD is used for, typically one example would be sizing the soil foundation interface, such as checking bearing pressure under a spread footing or a mat foundation. It's also the mechanism that we use to communicate with most geotechnical engineers in terms of using service level loads to calculate a bearing pressure that you could send to a geotechnical engineer for review and discussion. Then when we talk about LRFD, or ultimate strength design, that's commonly used for the concrete design portion of a foundation. For example, that would be designing and sizing flexural reinforcement in a spread footing, or designing or checking shear, either one-way or two-way punching shear in a footing, and then potentially sizing shear reinforcement if that's needed. And so what I commonly see as far as misunderstandings is really just incorrect application of the load combinations, specifically the difference between LRFD and the 2 types of ASD load combinations. Most specifically, the 2 types of ASD load combinations, which I'll explain to you in a minute. And then the other common misunderstanding is how to correctly apply factors for seismic loads to the foundation design. There's a lot of different factors. There's some reductions and there's some benefits you can take that are not always taken advantage of when you're designing foundations. So I'll walk you through those for a little more clarity. So just to start, I'll walk you through the 3 types of load combinations. As mentioned, strength design, everyone's familiar with these, probably use them on a day-to-day basis for concrete design and some steel design. Now the allowable stress load combinations, in IBC 2012, there's currently 2 types of allowable stress load combinations. There's the basic and the alternative basic. The difference is that the allowable stress design basic combinations, you'll recognize there's of course the dead plus live, and there's a 0.6 dead plus 0.6 wind, and a 0.6 dead plus 0.7 earthquake. Now, slightly differently, the alternative basic has a dead plus 0.6 wind, and a 0.9 dead plus earthquake divided by 1.4, which is essentially 0.7 earthquake. So you can see the clear difference is the factor on dead load for the overturning combinations of either wind or seismic is quite a bit more conservative for the allowable stress basic combination when compared to the alternative basic. And so I'll walk you through how we got there and some other things to be aware of when you're using these 2 different types of load combinations.